Today's session is G7 Calibration with Fiery Color Profiler Suite. It is my pleasure to introduce our speakers for today, Lou Prestia, Senior Product Line Manager, and Heather Blakely, Senior Product Marketing Specialist. So with that, let's begin. Lou, it's all yours.
Hello everyone. Thanks for joining our session today. Today we're going to learn about G7 calibration. We're going to give the example doing it on a cut sheet digital front end, the Fiery with Fiery Color Profiler Suite. Of course, there's many ways to do G7 calibration. We'll talk a little bit not just about G7 calibration for cut sheet digital, but we'll also talk about how this works for conventional presses. I want to highlight for you before I begin that if you're interested in the wide format G7, there'll be a separate webinar specifically about G7 for Fiery XF, and that takes place on September 13th. The other thing I wanted to share just before we start, we've got a tremendous amount of questions before we even started the session today over the last couple of weeks actually, and a lot of the questions are related to what do I need to do this. And so before I show you this, when we talk about it for digital or for conventional for that matter, in general what you need to do G7 is you probably need a spectrophotometer to measure the colors, or a spectrodensitometer on the press, and you need some software. And again, we're going to show Fiery Color Profiler Suite today. There's other tools out there to do this, but in general between instrument and software to do G7 you're probably looking at an investment of roughly $3,000 to $4,000. So I just wanted to give that background before we talk about this, since many of you asked, how do I get started? And so we'll talk a little bit more about that later. Why do people do G7? The number one reason for doing G7 is because you want to visually match one or more printing devices. The second reason is you want neutral grays, right? One of the big problems with all kinds of printing, both digital and conventional, is problems with keeping the gray balance. And one of the most obvious things to any observer, even if you're not a color expert, you're just print buyer or one of your customers that buys printing, is as soon as the print looks too red or too green or too blue in the neutral areas, like somebody wearing a white t-shirt or sometimes pavement or asphalt in an image of a city, as soon as things look colored in the grays, we know something's wrong. So gray is the most common visual reference color, and one of the main intents of G7 is to help to keep this neutral color. The other reason is you want a competitive advantage for your print business. By that I mean, when we G7 certify a software package, or when we get G7 qualification for a print shop, we are able to better market our product, okay? And in terms of you as a printer, if you're G7 qualified and in the master G7 qualified database, then that means that lots of your customers can look you up online, and you have a very good thing to talk to them about in terms of why they should buy their print from you, because you're this G7 qualified shop. And we'll talk more about G7 qualification later. So the agenda I want to cover today is I want to first give you some background and history of G7. I want to talk about where do these curves that we do G7 come from, the neutral print density curves, which is how we do the G7, talk about how we get those curves. I want to differentiate for you the difference between G7 calibration, which is, let's say, relatively new since 2006, and classic linearization that we've done for many, many years on all kinds of printing devices. We'll talk about the G7 process for conventional, and then we'll look at G7 process for cut sheet digital, and we'll use a Fiery server for this example in Color Profiler Suite, as I said. And finally, we'll close sharing some resources with you, including our how-to guide, which shows you how to do G7 if you already have Color Profiler Suite and Fiery, and some other learning materials related to that. So when we talk about the background of G7 and what is the G7 process, the answer is that the G7 process is the method of calibrating a press or proofer to a common grayscale appearance. What this means is that if I have a variety of printing processes in my shop, which you probably do, I might have some cut sheet digital, some inkjet devices, probably an offset press or two. If I take an image and I print it raw on all these devices, I don't even have to tell you this, it's going to look completely different, right? because each of these devices has different colorants, has different gray balances, and typically has a different density range. When I do the G7 process, if I take this image that I'm showing you that looks so different through these different processes, and I calibrate each of these processes to G7, I get this common neutral appearance. It doesn't fix all the saturated colors and other colors in the image, and we'll talk about that later, but it does fix the things that the eye are most sensitive to in this picture, such as the sky in the background and even to a lesser degree these blossoms next to the figure. These areas, when we print them as neutral on all these different devices, it tends to make our devices look the same. So the next question is, how do I do G7 calibration? And the answer is we do G7 calibration by loading these neutral print density curves, or the NPDC curves, on either our plate setter for a conventional press, or on the digital front end, the RIP, such as our fiery example today, for digital print systems. And so that brings us to the question of where do I get the NPDC curves? And the original answer, and still a valid answer today, is I can manually calculate these curves. This is not very applicable for digital printing, since it's different kinds of digital front ends have different ways that we load curves. But for conventional, where we can always load plate setter curves on a plate setter, this is the original way we did it. We get this fan paper from Idea Alliance, we get out our spectrodensitometer, we print test forms, and we can manually calculate the G7 curves. Almost no one does this today. So the second place we can get G7 curves is we can use a software tool. And there's a variety of certified software. We'll talk a little bit more about that later. The original example is the Curve software from Hutch Color and Chromix. The latest version currently in beta is their Curve 4. We will use Curve 4 today to show some examples of G7, but I want to be very clear that this is not required for the digital workflow that I'm going to show you. When we want to calibrate a fiery-driven cut sheet digital system, typically we would use Color Profiler Suite. This is another tool that is G7 certified, and this is designed to do the G7 calibration directly on the fiery server. So talk for just a minute about certified software. Certified G7 software is software that has been tested and approved by Idea Alliance for getting the ability to create neutral print density curves that bring a system to G7. Okay? When we do it on a cut sheet digital device, we not only show those curves, but in terms of the fiery, we actually apply those curves directly on the DFE, which I'll demonstrate to you a little bit later in today's talk. And that means that I don't have this business of having to get curves from some software from my fan paper and figure out a way to load them on the DFE. So it's a little bit more optimized and certainly a lot quicker to do it that way. So when I want to load the neutral print density curves on a conventional print system, I can either type them in the worst case, or in general I can import it on most of the front ends you probably have for your plate setters. And I can in fact load them on some DFEs in order to do digital output, but again, as I said, that's not as efficient, we think, as calculating it directly on the DFE with some connected software. And this is an example of what it looks like if I'm going to create curves. This is on a conventional system that I might use to drive a conventional plate setter. And you can see here all the dot values that I've gotten from generating my NPDC curves. And fortunately, in this example, this software lets me import the values so I don't have to type in all those numbers. The next thing I want to talk about is the difference between G7 calibration and linearization. Since probably many of you with some background in the printing business have some familiarity with linearization, I want to show you what that is and how G7 calibration is different. Generally, linearization corrects uneven tonal response, which means if my print system is printing like this, with a light tone in the first step and a darker tone in the second step and a still more darker or more chromatic tone in the third step, and then all the other steps of the scale are plugged up at that same value, I'm not very linear, right? And if I print without being linear, everything's going to look plugged up and terribly dark. So when I linearize a device, and this is true for a digital press just as it is for a conventional press, where today we linearize the plate setter, or historically we would linearize our image setter that made the films that we contacted onto the plates. Linearization just corrects this and provides even tonal response. Okay? It's a relatively simple exercise of measuring how things are when they're plugged up and then creating a curve on the print system or on the plate setter image setter that is the inverse of what we measured, and we get this even tonal response. So if I look at it in terms of a tone curve, we see that when I'm plugged up, I have a curve that goes up very quickly and is flat, and that when I am linear, we typically have roughly an in equals out relationship here. To some degree, this varies a little bit because of the fact that we measure in density. The logarithmic scale tends to make this look a little more bowed up in the midtone in some software. Final thing to note about traditional linearization is we did it for all the colors. Okay, so on a plate setter image setter, you do it once, all the plates or films are going to be the same. On a digital print system, if I have CMYK imaging, I'm going to need to linearize each color differently because typically they are applied a little bit differently in the digital print system. The difference with G7 calibration is that G7 calibration does more than linearization. I'm not here to tell you shouldn't linearize. Generally, it's best to linearize your print system before you do the G7 calibration so that on a daily basis we can come back and recalibrate, get back to the original linear state we based our G7 calibration on. Now we'll keep G7 without having to redo the G7 process every morning or every shift before you start production. But the results of the G7 neutral print density curve creation that we're going to do when we do G7 calibration is this. The curves are not linear, and the curves for CMYK are all different. They're different because in order to make the corrections that I need for G7, I need to change the tonality, and in some cases the contrast by definition, of each of the colors individually. I do this to get an even and expected and standard tonal response, which is defined by G7, and also to get that gray balance that I showed you on that earlier slide, which is one of the key things that we get from the G7 calibration. So when we talk about where G7 came from for a little bit of history, G7 is basically born out of the experience that we had, especially in the United States, with what we call computer to plate. In the 1990s, most of our workflows moved from film to CTP, these computer-to-plate workflows, and the reality is that we had depended for a long time on the way printing worked in the United States. So in the U.S. up until the 90s, we made negative working films. This film was cheaper to work with, and we contacted onto negative working plates, which were also cheaper than positive plates, and we printed. And because we had calibrated all our scanning systems and all our prepress to look good on these negative plates, it looked fantastic. But the reality is, those plates were not particularly sharp. We got a lot of dot gain on those negative plates. By contrast, the CTP process used positive working plates, such as people have been using in other parts of the world but not in the U.S. A positive printing plate is much sharper. The dots are much better formed, and therefore the dot gain is much lower. As soon as we took all the data that we had been printing on our presses up until the 1990s and imaged it onto a linearized computer-to-plate positive plate, suddenly our printing looks different. It looked very flat, and it tended to look very red because we no longer had the dot gain from the negative plates that our systems had kind of come to depend on, if you want to look at it this way. So during this transition, the quality of print in the U.S. suffered badly while people tried to figure out how to calibrate their plate setter so that it was not linear but made it look like the way they printed, let's say, last year when they were imaging negative working plates from film. I'll give you a couple visual examples of this. This is an example of a press test form run with no linearization. Okay? This is basically plugged up in the shadows. When I linearize the plate, such as we did in the 1990s when we first got these new CTP systems, I get things opened up, which is terrific. But I have a flat appearance now, and I tend to, based on swap separations, which we'll talk more about in a second, have a reddish appearance. If I now do G7 calibration to this press and change the curves that I'm using on my plate setters so that they're not all linear, but so that they conform to the G7 specification, Now my printing looks like this. I get back that punch, that contrast that I always had in the printing before, using these same separations, and I get the neutrality. Okay? So let's dig into this press test form a little bit here. I want to talk about the P2P target. This is the target that we show in this particular, this is a 100 centimeter 40-inch press test form, so we typically run this twice on this form because it fits. But the P2P target, or the proof to print target, is the basis of all the G7 calibration. So whether I'm going to measure it by hand and use the fan paper, or whether I'm going to measure it with some other kind of more automated spectrophotometer and bring it into some software, I'm going to use a P2P target that I print on the print system, whether it's conventional or digital, number one, to find the correction values to create the neutral print density curves, and then I'll print it again, what we call the qualification run, to make sure that I actually got to G7. If we look into the details of this target, the first three columns show me solids and tints for the three-color primaries and the three-color overprints. So that's the cyan, magenta, yellow, and the overprints of red and green and blue. We use this two ways in the G7 process. The first thing we do is we use the tint curve, or the tint values for the CMY to figure out what the neutral print density curves are going to need to be to get G7 tonality. We also use the solids for both the CMY and the RGB so that we can try to get our printing process to conform with this ISO 12647. ISO 12647 tells me how the solid color should look, and it helps me to do something beyond simple G7 calibration and actually get the saturated colors to match as well in my printing process. We'll talk a little bit more about that later. The fourth column is black tints. For G7 calibration, I target the black tonality different than the three-color CMY tonality. So I have a little bit bigger scale here. I can get a little bit more precise measurements of how the black is going to be corrected using the neutral print density curves. And then in the fifth column, I have a very important thing. I have three-color gray balanced builds. This is the CMY that's in all your color separations, all the CMYK data in your shop. It's supposed to print as gray. And I won't go through all the examples, but if I looked, for instance, at the 50% patch in this fifth column, you'd find that it has 50% cyan, 40% magenta, and 40% yellow, which is classic gray balance for a conventional press, and that's what's come out of all the scanners and all the software that's made color separations, pretty much everything that's in your shop. The rest of the chart is used for corrections. Because we have to correct neutrality, these gray finder patches out here help the software or the manual process to figure out what the ratio between the C and M and Y curves in the NPDC curve should be in order to get us to this great neutrality. So how did G7 solve this CTP problem that I talked about? The answer comes that almost all the separations in the world since the 90s, mid-90s, have been made from Photoshop, right? Everybody familiar with how separations are made in Photoshop? Typically, when we get some RGB into the shop, some designer or pre-press person or something says, I got to make that CMYK. And they go under the image menu in Photoshop to mode CMYK color, they save the file, and you move on. No more RGB in that job, especially when we had all conventional presses, we had to do this. What does that do? When I convert the colors to CMYK in Photoshop, the vast majority of the time, I'm looking at the Photoshop color settings here, I convert it to this profile called US Web Coated Swap version 2. Okay? What is US Web Coated Swap version 2? US Web Coated Swap version 2 is the first printing standard ever published in the United States. This is from the data set we call the TR001 reference. We created this by printing on about a dozen web offset presses, averaging together all these targets, and creating a standard data set called TR001 from which the profile in Photoshop was made. And basically all the swap profiles you've seen, at least up until 2006, were made from this TR001 data set. So the question we have to ask ourselves is, if all the separations in your shop and in the world pretty much match this TR001 gray balance and tonality, how can we fix that with G7? So the question is, will G7 calibration, even on a conventional press with no color management, give me the same thing that I expected in Photoshop, the swap appearance? And the way we're going to find out is we're going to take the P2P target. Now I'm not going to print the P2P target in this case. I'm just going to apply the US web-coded swap profile to it. I'm using the Chromix ColorSync software to do this. When I apply it to the reference data set for the P2P, I can now save the P2P essentially with that swap profile applied. The next thing I'm going to do, and this is not for you to try at home, I'm doing this purely as an example. You don't need any of this software to G7 calibrate your digital print system. But I am going to use the Chromix Curve 4 software to show you the results. So this is the P2P values that I've applied the swap profile, the TR001 values to, and I bring it into Curve, and it's essentially perfect. In fact, you can't see the difference between where the target lines and where the actual lines are in the Curve software that shows me if I've achieved G7. Also, if you see these highlighted areas, all the G7 statistics are green, which means that I am passing G7, what we call the G7 grayscale definition, which we'll talk a little bit about later. If I look at the solids in this result, you'll see that I'm actually also matching the ISO 12647-2 solids. So technically, if we had actually printed this result and measured it, we'd be not just G7 grayscale, but we'd be a higher level of G7 that we'll talk about a little later, where I not only match the neutrals and the grays and the tones from the highlight to midtone, or I actually also match the saturated colors. So this brings us to the next question for some of you on the session today and some of you that may watch this later online. What if I'm not in the United States? Do I care about G7 calibration? And the answer varies from shop to shop and from region to region. But in general, G7 is not widely adopted outside the United States with the exception of a few countries in Asia. So I wanted to do the same experiment to talk about near neutral calibration, which is typically what the similar process is called when we do it outside the U.S. and we're not targeting G7. So just for interest's sake, I took a European reference data set. This is the ISO Coated data set called Fogra 39L, and I did the same thing. I applied it to the P2P patches just so we could look at it in the Curve software, and you see that in fact the Fogra data for Fogra 39 is actually relatively close to G7. The black isn't defined quite the same, but even if I was trying to print some kind of Euroscale or ISO or PSO separations in some other country, G7 pre-calibration of my press would give me the same benefits that it gives me if I'm trying to match Grackle or swap in the U.S. And you see that those solids are also consistent in that Fogra 39 data set. They also pass this ISO 12647 definition. So let's talk about the certification programs for a minute. The first one I already mentioned is the G7 certification. Now it's a little confusing. There's a certification program for software, such as the certification the Color Profiler Suite has. There's also G7 certification for people. So if you're in a plant and you want to do G7 calibrations, you might send somebody to take the class to become a G7 master or a G7 expert. These are two different levels of certification. Or in some cases, some shops will hire an expert that has these qualifications and have them come in to do the G7 calibration, or at least to do the part of it where we submit some forms to ID Alliance to get a different qualification for the shop, which we'll talk about in a minute. When we talk about print system certifications, there's a Fogra program called Fogra Cert, and there's a separate ID Alliance program called the Digital Press Certification. Neither of these are a G7 certification of any form, but these basically show you that the press you are buying is qualified to do all this stuff. And generally, if you have the ID Alliance Digital Press Certification, it's qualified to do a lot more things too, as we've talked about in separate World of Fiery webinar. This is a test not just of the colorimetric accuracy of the press, but of repeatability and durability of prints and other things. So the operations programs, which is to say the programs that you can get applied to your shop, The number one thing, since we're talking about G7 today in the U.S., is the G7 qualification program. And if you're going to do G7 qualification, you not just do G7 on your device, you have to print some special forms and submit them to Idea Alliance in order to earn this qualification. That's another case, as I mentioned a minute ago, where sometimes someone will hire a G7 expert or a G7 professional level person to come in and help them do this. There's also in Europe a Fogra program called PSD Certified for Process Standard Digital, and this is another program that we can do in the shop. And as I said, we have talked about this we had a World of Fiery on press standards in the past, and you can probably find that online if you want to watch a recording of that and you didn't attend that. The other thing I want to talk about before we move on is the different levels of G7. Now, I referred to this a couple times earlier. The first thing is G7 grayscale. G7 grayscale says I've loaded neutral print density curves on the print system, and I'm matching the G7 specification in terms of tonality for my 3-color, tonality for my black printer, and in terms of gray balance for the 3-color. This mainly applies from the highlight to the midtone. It becomes a little bit differently defined when we get into the 3/4 tone because of the different density range of different print systems. But if I'm G7 grayscale, I'm going to get that neutral grayscale appearance that I showed you on the early slide, the second slide or so. The next higher level of G7 qualification that I can achieve is I can be G7 targeted. G7 targeted presses not only match G7 definition for the NPDC curves delivering what we expect in the highlight to midtone, but it also means that we're matching the solids. So remember I showed you a couple of plots of the solid colors in the curve software? That's a test to see if our solid primaries and overprints match this definition called ISO 12647. And if I get to the G7 targeted level, now I have a print system that not only has the neutral print appearance, but also will tend to render saturated colors in a very consistent fashion from one printing device to another, or from one substrate to another in a single printing device. The higher level than that is called G7 color space. Color space is where I achieve G7 targeted, but I also match the entire gamut for reference color space, usually Grackle, although we can do G7 color space with any definition, but it means I have to measure the big IT874 target, the 1617 target, in order to see if I comply with the G7 color space definition. The last one that I don't want to leave out is a different kind of G7 category. It's called G7 Extreme. G7 Extreme basically means I've done the G7 grayscale part, and now I'm going to run the solid ink densities up as high as I reasonably can on my conventional press. Or in terms of conventional press, a digital press, I'm going to disable some part of the color management so that rather than trying to hit the solids of 12647 and having everything look consistent from sheet to sheet and press to press, instead I'm going to make the most saturated, colorful prints that I can. Okay? Interesting. Generally, if you're in the business of printing and having to make reprints or having to match multiple systems, G7 Extreme is not very applicable for that. If you're making art prints or one-of-a-kind prints that you're not going to have to do again, then G7 Extreme might be interesting to you. So let's talk about how we do this. The first thing I'm going to talk about is G7 for the conventional press, and I'm going to start you with some best practices in case you haven't been exposed to this yet or you're thinking about doing it for your conventional presses. The tips that I can give are order much more paper than you think you need. The G7 expert will tell you that it's going to take probably 2,000 to 4,000 sheets to do a G7 run. I'd order twice as much paper as anybody thinks you're going to need. You don't want to be in the middle of the day with your experimental NPDC curves just loaded on your plate setter, trying to do a second run to see if you achieve G7 and running out of paper. So that's probably the single most important bit of advice I can give you. The second thing is whether you're in the calibration run, which is where we run just linear plates from the plate setter, and we print P2Ps to find out what our NPDC curves need to be, or if I'm in the qualification run after I've loaded NPDC curves and I'm running the press a second time to see if I've achieved G7, once I get through make ready, get the press up to color and get it nice and even across the sheet and around the cylinder, run at least 500 sheets. I'd run 1,000 sheets. It's a shame to put them in the recycle bin, but you really need to let a conventional press run in before you start measuring to see if you're in a certain standard or certain reference such as G7. Last tip, remember to run your press at production speed. This has a fairly big impact on offset. If you're doing something like flexo, this is absolutely critical. The press speed influences your dot gain, so if you jog the press along thinking you can get this done with less sheets and less ink, when you go run later at full speed, you're going to have different dot gains and your G7 is going to go out the window. Okay, this is the form I showed you earlier. This is a classic G7 test form. You can download these from the internet. Idea Alliance offers them in all kinds of different sizes and shapes. If I'm on a 8-up press, I'm probably going to run a target like this one that has all my, or a form like this one that has all my targets 2-up and rotated. This allows me to factor out variability across the sheet and around the cylinder by averaging these together. Okay? Also, a super important thing for digital, which we'll come to a little bit later, if I'm going to measure a cut sheet digital device, I'm going to try to do G7, and I measure just one P2P down the middle of the sheet, the variation on the digital press across the sheet and from sheet to sheet is probably going to keep me from having a very stable long-term G7 calibration. So basically, I'm going to run this G7 test form twice on the conventional press. I'm going to run it with linear or roughly linear plate setter curves, and you should talk to an expert before you do this. Generally, we don't do a, 50-point linearization of a plate setter. We typically just move the midtone to get the plate setter linear so it's not too wiggly when we put the NPDC curves on top of it. And then we'll take these P2Ps, we'll choose a number, 5 or 10 or 20 forms from our run that have very good density values, very good consistency across them and around from top to bottom, and we'll cut out the P2Ps, measure the P2Ps, average them together. We can measure these in lots of software. There's X-Ray software, Fiery Measure software that comes with Color Profiler Suite, can be used to measure your P2P targets. And then we load these curves somewhere. So if I'm doing a conventional press, I'm going to use one of the many certified systems out there. Today I'm talking about Curve and showing you the Curve 4 software. Once I load the P2Ps into Curve, Curve has this window called Create Curves, and I basically configure my settings there and export the curves, and then I load them on the plate setter. And that looks roughly like what I showed you near the beginning of the presentation when I showed you that screen with all the values in it. Next thing I'm going to do is run the press again, this time with the NPDC curves loaded onto the plate setter, the correction curves that I got from my certified G7 software. We call this the qualification run. I'm going to do the same thing. I'm going to bring the press up to color. After make ready, I'm going to run it in for 500 or 1,000 sheets. Then I'm going to start taking pulls every 100 or 200 sheets, collect 5 or 10 or 20 acceptable forms that are very even from gripper to tail and across the form. And incidentally, I'm going to let these forms dry back. I forgot to say this. If you don't have a coater on your press, your offset sheets probably should dry back overnight before you measure them, both for the calibration and the qualification run. And then I'll bring it into the Curve software again to see that I've achieved G7. And assuming I have, I can move on and make a profile from those IT8 targets that were on my form, which is optional, but is kind of the best practice if you're doing digital proofing. Okay, if you have a Epson proofer that you want to match your press, you can do the G7 calibration. Minimally, you should measure the ICC targets to see if maybe you got all the way to Grackle, maybe your G7 color space, in which case you could just make Grackle proofs. What a lot of shops do is they take the profile they've created at this point and they use it for their digital proofer from their inkjet. So let's talk about G7 calibration for the cut sheet digital press. Give you some best practices here to start with. The first thing is on a cut sheet press, we typically, not on all of your print systems, but on many of them, there's some kind of engine calibration. So we do some things like the correction of the offsets where the dots start to print. We can also on some presses do some correction of the density values or the imaging of the press, both across the press and around the cylinders or along the belt, so we get it evened out from this engine calibration. This is something you do from your press LCD panel. The second thing is we're going to run a lot of warm-up pages, somewhere between 5 and 35 depending on your press and how cold it is. What a lot of shops do when they go to do the G7 or even simple calibration is they'll put on some job that is really non-critical for color, maybe even black and white job, and if you run a job like that to warm up the press, then you can skip this warm-up pages step. The last thing, as I said a minute ago, we're going to average multiple P2P measurements from a sheet that we print so that we factor out some of the spatial variability around the press form. Same idea that we do on the conventional press. The next thing I'm going to do is I'm going to use some software, and I'm going to talk a little bit about our own software today, about the Fiery Color Profiler Suite. Fiery Color Profiler Suite was awarded the G7 System Certification in May 2016. This is the first software package that does G7 calibration directly on a digital front end that earned this certification. Ideas behind the product, you won't be surprised to hear me say, you've heard me say on lots of others of our webinars, that we want to create software that an operator of any skill level can use. So you can get your G7 expert, your G7 professional certification. It's great for you to get that education, have somebody knowledgeable like that inside your shop. If you're doing this on conventional, you pretty much have to have somebody like that. For digital, if I'm going to sit at some software package and do it right on the DFE and right on my press, we wanted to make it so anyone could do that. And so the function that we're going to show here is that the Color Profiler Suite process, when we do the G7 calibration, we take the correction curves, the NPDC curves, and we load them directly into a calibration set on the Fiery server. So basically the workflow after that is no different than before G7. You continue to pick your output profile, which picks up your Fiery calibration, only now it's a G7 calibration, and then we'll see in a few minutes how we can recalibrate that over time. So this is the workflow that we're going to go through in this demonstration. We're going to do Fiery calibration, then we're going to do G7 calibration, then we're going to do the ICC profile. Before I get into the demo, let's talk for a minute about why I would calibrate the Fiery before I do the G7 calibration. And this goes back to the examples that I've given from the conventional press. I want to linearize my system, get it unplugged, let's say, and get it in some known state before I do the G7 calibration. Then I'll do the G7, create a profile. The benefit of this approach is that every day or every shift when you come in the shop and recalibrate your DFE and your digital press, the way you do today, you'll do it exactly the same way. You'll just be relinearizing the Fiery like you already do today, only when you relinearize it, the G7 curves and the ICC profile that rests on all that will be corrected as well. A lot of questions about this, and we're going to get to questions at the end here, but a lot of the pre-submitted questions were about what do I need, how much does it cost, and how long does it take? And I didn't show you this for conventional. Conventional, depending on whether you have a coder on the press, it's probably going to take you a couple days. If you had a coder and a really good crew and a pretty modern press with good grippers and stuff, you might be able to do one form, one substrate in one day, but it'd be a pretty long day probably. On the digital side, it varies with the tools that you use. The example that I'm going to show you today in this demo, we do a G7 calibration and profiling in about 30 minutes. This is with a handheld ES2000 or like an I1 spectrophotometer. We obviously cut 10% or 20% off this time if we get into a scanning spectra such as our ES6000 or a ISIS or a FD9 from Konica Minolta. So let's see the demo. To do the process, I'm going to launch Color Profiler Suite. I'm going to launch the Printer Profiler module. Notice that I'm in the Fiery calibration step right now. I'm going to set up my session, so I need to give a name to my session and connect to my Fiery. Remember, we're going to do the G7 right on the DFE that's connected to your press. And I'll go next here. In the next screen, I'm going to tell the software that I want to create a new Fiery calibration set and that I want it to be G7 targeted. I want G7 gray balance calibration, not just the traditional calibration by itself. Click the next button. And now I have to pick my device that I'm going to measure with, and I am using an ES6000 for this example, and the patch layout. Lots of discussion beyond the scope of today's World of Fiery webinar. Generally, a larger patch set is the best thing to choose because the more samples we get, the better we can calibrate the digital print system. Choose the paper size and click Next. At this point, we print the job. So we've set up all our job properties for how we're going to use this calibration and G7 calibration and profile. We measure the target, and we move on to the G7 step. So now we're into the G7 calibration. On this screen, I need to pick a different target. I need to pick the P2P that I'm going to use to do my G7 calibration and qualification. We offer you a few choices here. We do offer some randomized choices, which is a little better choice on a digital press because of the spatial variability around the page. We also have this 2-up target. That's the one that I recommend you use. Not only does that randomize the samples, it also has 2 of every sample. That's why it is 2-up. We average those 2 values together, so you get the effect of averaging, such as we do on a conventional press, without having to print and measure a bunch of different forms and figure out how to average them together before you continue. So this all comes out on one sheet. Again, we measure the P2P 2-up. And we see our first result. You can see from the red results at the lower right that I have not achieved G7, and I didn't expect to. This is the G7 calibration run. I had to print the P2P to see where I am with respect to G7. Now in this particular example, I happen to have one passing result. When you try this yourself, you'll see all different things. Sometimes a lot of this is green on the first pass, but I would never expect this to be a perfect pass. I haven't measured the information, the P2P, that I need to create the neutral print density curves yet. So we'll click the next button, or sometimes in some of the software it says iterate, and we're going to measure another P2P that has had our neutral print density curves applied to it in addition to the fiery calibration. Now you see that we've achieved G7. So you see the green results in the bottom corner. That means that I am G7 grayscale minimally. Okay? Now I want to do an experiment here. I want to validate this with some other software. So I'm going to show you the curve software from Hutch Color and Chromix again. And I want you to be aware that this is not required to do G7 on your digital press. It's a pretty essential tool if you're doing G7 on other print systems. And there are some other qualified or Idealine certified software packages you could consider. But I want to use Curve 4 just to validate this result from the firing. So I've taken a P2P and I've printed it through this calibrated system with calibration only. And the difference that you see is that before I calibrated, I'm a million miles from G7. You can see that the green target is the green curve is the target, red is the actual. I'm nowhere near the target. I have all red results as shown at the right, so I'm failing. When I print with the G7 calibration that I've just created, I'm now G7 grayscale. All these green values shown at the right here tell me that I'm matching the definition of G7 for the neutrals, in the mid-tone to highlight, and even in the three-quarter tone. Okay? I'm not done here. I'm just showing you an example in the middle of how we got to G7, and I'll tell you why I'm not done. If we stopped right now, which lots of people are tempted to do, they say, well, G7 is good enough. I'll just run without color management. I'll use calibration only. Be aware that if you take that approach, your solid colors won't match. Remember ISO 12647-2, the solids that we also measure from the P2P target? For a pure calibration, even a G7 calibration on any digital print system in the world, you're not going to match 12647-2. Unless you could somehow take the inks from your offset press, which are 12647 compliant, and put them in your cut sheet digital device, or your inkjet device, or your grand format device, you're never going to match 12647 without further color management. So I'm failing what we call G7 targeted. I got grayscale, but I didn't get targeted because I didn't get the solids. Now I'm going to make the ICC profile. And so if you're doing the workflow, you'll never see the curve software. I just took a break there to show you what we had done. The very next thing you would see after that passing G7 screen when you click next is this screen. This screen I picked the target that I want to use to make my ICC profile. I'm using an ECI target here, 1485 patch target. I'm going to print and measure the profiling patches. These have the fiery calibration and the NPDC curves that are built into the fiery calibration. the 2D lookup curves that G7 certified software is required to create applied, and now we're going to measure the results of the output in order to create an ICC profile. The end of this process, the profile is created, and one of the things you may already know if you're familiar with Color Profiler Suite is that when I do one of these workflows in Color Profiler Suite, we don't just make the calibration, and in this case do the G7, and make the profile. We also make you a server preset on your firing. So now it's super easy to apply this to jobs, set up an automated workflow, make a virtual printer, use it in a hot folder, simply instruct everybody in your shop that this is the way they're going to print things on a certain paper, is to use this preset. This preset chooses all the print settings that I used, excuse me, so my resolution and my halftone, etc. And it also chooses, very importantly, the calibration that I created, which includes the G7 calibration, and the profile that works with that calibration. So again, if we take the final result and look at it in curve, not required to do your firing, but just to show you the results, once I make the profile and I measure a P2P, I can show you that I'm not just achieving G7 grayscale in curve 4, I'm achieving G7 targeted. Can't tell you about color space because color space requires that I print an IT874 and I didn't print that data, so this doesn't have enough information to give the result. Okay? Again, just using curve to give you an example. You can also check this in other software, including in the Verify module that comes with Color Profiler Suite, but if you're doing G7 for a bunch of systems, there's a good chance you have the curve software, and so that's a good way to validate this, at least for our examples today. So, talk for a minute about calibration, because there's one missing piece in this workflow that I showed you. And that's the part where I verify compliance, and then, going forward, when I recalibrate my Fiery every day or every shift, whenever you do it, using your standard 21 or 34 patches you always do today on your Fiery, I get back to G7. If I want to continue to verify compliance, I can certainly do that. We can use tools like the Verify module in Color Profiler Suite, the Fiery control bar, and other tools to verify our compliance, maybe every time we calibrate it for that meticulous or on some kind of a regular basis, so we know if the calibration is getting us back to the G7 that we targeted. So a quick review of what we've learned. First thing, we talked about the background and history of G7. We talked about where do we get these neutral print density curves to do G7. The answer is generally from some software package today. We learned about the difference between doing a simple linearization of a print system, which makes it tonally even, and doing a G7 calibration, which gives a tonality and gray balance that is targeted to match the way our separations are coming to us. The swap data, which is very similar to Grackle and all the other standard data you get today, prints very well on a G7 calibrated system. If I do the G7 calibration before I make my profile is going to last longer, and my profile is actually going to be a lot more functional, especially around the neutral axis, where it doesn't have to do a lot of jumping around to keep things gray since we've already neutralized the press doing G7. We talked a little bit about how to do this for conventional, how to do it for cut sheet digital, in this case using Fiery and Color Profiler Suite, and we want to share with you a couple more resources. I'm going to turn it over to Heather for a minute to talk to you about this.
Great.
Heather?
Thank you very much, Lou. So we have quite a few resources here available to you. And once again, this presentation will be made available to you with these hyperlinks to these resources when we send out the thank you email in a couple days with the link to the recording. I know many of you have asked about the recording session, so that will be made available to you shortly. So first off here, you can go ahead and visit efi.com/cps to access product information and download the latest brochure, access links to watch the short videos on color, and also to download the free demo of our software that you've seen the demo today. Then we have a link to our Fiery Color flowchart, which is comprised of a PDF that we show the recommended Fiery DFE color settings. And it also has a link in this PDF to the video where Lou walks you through all the settings and how it changes and affects the flowchart. You can also visit help.efi.com/cps for detailed product and help documentation specific to each version. And then you can download our G7 how-to guide for step-by-step instructions of how to create the G7 calibration and profile like our demo you've seen today. We also have a free G7 simulation learning that allows you to actually click through the workflow and get a good feel and understanding of how the process actually works, since available at our training.efi.com. And then as mentioned, for the advanced G7 workflow, you can follow this Verify How-To guide for compliance with industry references, and that's coming soon. Hopefully we made available relatively shortly. And then finally, we also have a link to download the P2P target that was shown in this presentation for a quick access right there. And also don't forget to visit our Fiery forums for colored imaging as well as CPS to make sure you can ask the experts such as Lou any of your additional questions. And just like today's session, we have quite a few other World of Fire webinars on color topics. So here's a couple links to the ones that we've done in the past so you can access the recorded sessions of those. And with that, we will now go ahead and start our Q&A session.
Right. So I think we have quite a number of questions that were submitted during registration. Hopefully some of you got answers as we were going through the presentation, but we also have a good number of questions our audience submitted. So let's see how many we can fit in the next 6-7 minutes.
Yeah, so before I start, we're going to run out of time. We can run a little bit over if your time permits. You're welcome to stay on the line. We are going to cover questions both that were pre-submitted and the ones that you're submitting right now, so don't hesitate to put in more questions. As we always do with the World of Fiery, we run out of time on the questions, so you can expect probably next week sometime we will send out a link or a FAQ which includes all of the questions that we were submitted and all of the answers to all of those questions as well. So don't hesitate to ask more. I do want to, before I go on, also point out again the Fiery forums that Heather just mentioned. A lot of times, if you're having a particular problem with printing, the place to start is the Fiery forums. You're welcome to submit those questions, and I'll certainly try to help you. But a lot of the time, I need more information. So you'll see, if you've seen one of our facts in the past, some of the time I say, we're here to help. Please go on the forum and post the questions so that some expert, maybe myself or somebody else in the FI or some of our very smart customers out there, will say, sure, I can help you, but I need to know this and this and this. And then you get answers to those specific, like why is this happening, why is something working or not working questions. So, starting from the list here, I have a question about, is G7 an add-on to Command Workstation? And the answer is not really. Color Profiler Suite is a Fiery option that can be purchased to use with your Fiery. It is accessed or can be accessed from some touch points in Command Workstation, but it's a standalone software package designed to make profiles for your digital press and all your other presses. It also has a number of other features in the suite I won't talk about, but that's where the G7 calibration is. So if you want to do G7, you need some tool, and of course the tool that is at least easiest to use with the Fiery and the one we would recommend is our own Color Profiler Suite. Next one, a lot of people ask this, can I do this on model this? Which of the copiers and the digital presses support this? And the answer is Fiery Color Profiler Suite supports Fieries back to System 9R2 and can do this process on any Fiery back to System 9R2 if you want to. Doesn't matter what your press is, which manufacturer made the press. If you're driving it with a Fiery and you have a fairly modern Fiery System 9R2 or 10 or newer connected to it, you can use Color Profiler Suite to do this. Next question, excellent question. Somebody says, what if I want to do G7 on uncoated paper? This is a super common question. You know, designers love like matte sheets and stuff like that. Stuff that isn't coated, that isn't a #1 sheet, is not going to match Grackle, right? It's not going to have the gamut to match Grackle. But I can certainly do G7 on uncoated sheets. In fact, I recommend you do this too. Because who would want the uncoated sheet to not print neutral and to not have the proper contrast in the highlight to midtone? The only thing I'd do different if I was printing on an uncoated sheet and I really wanted to have a controlled and predictable process that I could verify and do verification against is I'd choose a different source. I wouldn't kid myself and say, I'm going to match Grackle or I'm going to match ISO Coated on this matte paper. I'd instead try to match some uncoated reference. So there's an uncoated reference from ID Alliance and from CGATS in the CRPC dataset published in 2013. There's Fogra 52, which is the basis of the PSO uncoated profile in Europe. If I had a little better sheet, I might do something like SWAP 3 or SWAP 5 in the US. These are absolutely G7, but they don't have as big a gamut as Grackle. Since when we go to a SWAP 3 or SWAP 5, we go to a lower quality paper, we have less gamut, and that's essentially what you're doing on the uncoated. Okay, the next one is, should this start with designers? So the question is, what good will G7 do me if I don't get control of this upstream? I have super good news for you. There's loads of things you've run into in your business where you're like, I have to go educate the designer because the designer's sending me RGB, because the designer's sending me things that I can't print, because the designer's looking at reflex blue on the screen and thinking that I can match that on my press and I can't. This is an example of the opposite case. The designer upstream is already setting you up for G7. Assuming you've taught them to convert RGB to CMYK in the past, they're doing that image mode CMYK thing in Photoshop. They're making you G7 ready data. They're sending you swap or Grackle separations that are going to run excellent on a G7 calibrated and profile digital system. Next one is, will the profiles that I create in Command Workstation be compatible with G7? Well, I want to take this question two ways. First, to explain, you can't make profiles in Command Workstation. Yes, you can edit curves and profiles in Command Workstation. This is a bad practice in my opinion, because every one of your operators is going to edit every one of your profiles a different way for every single job. You're never ever going to be able to match a reprint, because you're not going to know which edited profile which person used with which job on which day. So if that's what you're referring to, that's not making a profile. We make profiles in Color Profiler Suite. Will they be compatible with Command Workstation? Naturally, that's where we pick these things, usually using that preset that Color Profiler Suite created. The other facet of this question that I want to cover is, if I G7 calibrate my press with, let's say, Fiery Color Profiler Suite, and I then want to use a factory profile, rather than the profile I made to work with the G7 calibration, if I choose one of the default factory profiles that shipped with my Fiery, will that work? Probably not. Those profiles historically were made before we were doing G7. They expect a linearized Fiery that isn't G7 calibrated. So just to answer if that's the question that's being asked, no, I wouldn't use a default factory profile with a G7 calibration. I'd do the whole thing in Color Profiler Suite, calibrate the Fiery, G7 calibrate the Fiery, then make a profile that works with that calibrated system. Next question, a little bit off the track of G7, but I want to cover this because I bet other people might have this question. This question is about making spot colors. And this is about someone that is taking spectral measurements using their ES2000 and Command Workstation in the Spot On or Spot Color module, and they're measuring paint chips. And they measure the paint chips, and then they put those colors into a document, and they print, and it looks great. But the question is, why do those values fail when I use them in Adobe Illustrator? And the answer is, when you are creating spot colors on the Fiery, or using Spot On, you're creating them in the context of a Fiery output profile, right? That's your working space, if you will. We're showing you the CMYK. We need to print that with the output profile that's currently selected in Spot On. When you go into Illustrator, Illustrator, assuming you made a CMYK document, is thinking in some standard space. Illustrator probably thinks you're in Grackle or swap space. So the way to take these colors to Illustrator is not to type in the CMYK values from Spot On. Instead, look on the left side. Look at the LAD values that Spot On is showing for that measurement. Type those into Adobe Illustrator, and now you'll have the same appearance. Remember that the colors in Illustrator should be named the same way that you've named these chips that you've measured in Spot On, or when you print the job, the spot colors won't get looked up properly. Next question. Specific to the making of the profile in Color Profiler Suite, the question is, which black channel edits are most common and most effective when color verifying to ISO 12647-7? Okay, a couple of questions put together here maybe, and I want to go through each of them. Firstly, setting up the black and color profiler suite is as easy as we think we can make it. It automatically takes the black from the factory profile for the similar paper. Okay, depending on how you've connected to the Fiery, this might not work exactly that way. When you get into that profile settings window in Color Profiler Suite, look up at the very top. If it doesn't show you a factory profile, has a big F at the end of it, for your press, for a paper similar to the one you're profiling on, then go pick that. And if you're profiling offline, you'll have to connect to the Fiery to pick it. Totally worth it. That pulls in the black settings that our experts use to make the profile that the press manufacturer approved. So it's always the best choice. If you want to get a little bit better stability, a little bit better neutrality, probably a little bit longer lasting match, I would also enable the control in there that says max or maximum GCR, and I'd make the profile. Wouldn't make any other edits. Okay? Second part of the question, if I'm trying to verify against something like ISO 12647, you said -7, which is a proofing reference, pretty hard to match on a cut sheet digital device. If you're doing it, more power to you. Most people use the ISO 12647-8 verification. This is the one that Fogra and all the other standards organizations around the world agree is the right one for cut sheet digital. But regardless, one other thing to remember, if you're doing a verification, you need to turn the gray processing off on the Fiery. So you need to go to the setting for the gray, for CMYK, where we can print gray using black only for text or images or graphics. And you need to turn that either off or set it to text graphics so that your images aren't having the 4-color black converted to 1-color black. Yes, you want to print that way if you're doing black and white jobs because you want black and white clicks. I totally understand that. For purposes of verification, if you don't use all the colors in the blacks, you're not going to comply with the standards. You're not going to match the G7, and you're certainly not going to match the 12647-2 definition of what black should look like, which is part of your 12647-7 or 8 verification you want to do. Does the software work with Pantone is the next question. How to better match Pantone? How can G7 help me match my spot colors? Well, the answer is G7 gives us better stability and longer lasting profiles, which means your spot colors, if you're adjusting them, probably have to be adjusted less often. But in general, a spot color on a digital print system is looked up from the Pantone library, which yes, it's compatible with. We are Pantone certified. We're licensees of Pantone. If we see a Pantone color in a job, we look up the correct tint values to print it with through your output profile. We automatically print that. If you don't like it, you can go into Spot On and you can edit it or print variations. If you have Color Profiler Suite, you can actually optimize the spot color with spectral measurement by measuring it with your spectrophotometer to reduce the delta E of that spot color. But all of that works with any output profile. So it doesn't matter if you've done G7 or you haven't done G7 or when you do G7, which I assume you probably will, it's fine. At that point, we'll create another lookup table on the Fiery that looks up all your spot colors through the new output profile that is the G7 based one, and things should work exactly or perhaps better than it does today, but similar or better. Question about what version of software I showed. I showed Color Profiler Suite 4.9.3, which is the latest release. The G7 feature was added in 4.9 in May. If you're a CPS customer in your contract, your software maintenance and support agreement is active, you're qualified already. You can download 4.9.3 off EFI.com. And a question about the Mac, yes, all our software is, I would say, by definition cross-platform. So this runs on a variety of Windows and Mac OSs, not just the current ones, but also going back a couple. Next question is to differentiate G7 from the corresponding Curve 4 features. I see this G7 feature. So I guess the question is, what's the difference between the G7 in Color Profiler Suite calibration and the G7 in Curve? And the answer is, the one in Color Profiler Suite applies it directly in the Fiery calibration set. The G7 tools in Curve allow me to create NPDC curves for any print system, and I can load them on most print systems, but to load them on a DFE, including the Fiery, very challenging. There's a way you can do it if you have the Graphic Arts Package Premium Edition, and if you absolutely had to just do it with curve, that's what I'd recommend you do, is get the graphic arts package, and then you could load those curves into your Fiery, but it's complicated and time consuming. I'm not suggesting you don't need curve. You need it for all your other print systems, but it's not as helpful on the Fiery as having Color Profiler Suite.
So Lou, let's take just one more. We're close to 10 minutes over, so one more question. And as Lou mentioned, anybody who had a question, we will get back to you personally with an answer. We'll also compile all the questions and the answers to those questions in one document and send that out to everyone, so you'll have that to refer back to. So last question for today.
I'm going to take an easy one, but an important one. There's a question about whether I can do this if I have an embedded Fiery controller rather than an external server, and the answer is absolutely. Our Color Profiler Suite tool runs on your client side, so it runs on your Mac or your Windows machine, or you're connected to that Fiery, maybe where you have Command Workstation, although you don't have to. Any system in the shop that can talk to that Fiery, or let's say can print to that Fiery, you can run Color Profiler Suite, send the targets, do the calibration, G7 calibration profiling, all the things Color Profiler Suite does works exactly the same on an embedded Fiery controller as it does on an external server.
All right. So I want to thank everyone for staying with us over. We, as I said, have a lot more questions we're not going to be able to get to. I did notice that a few people asked about the G7 for Fiery XF and Fiery Pro Server. So I want to reiterate, we do have a session scheduled for September 13th. You can already register for that session. You can find that listed on our webinars calendar on EFI.com. We will also send a link out with our email just for all those of you who are interested in checking that out as well. So more G7 coming to you after the summer break. Obviously, as we have additional World of Fiery webinars, we'll make those available. Always good to check our webinars calendar, but we'll send out emails as those sessions get solidified and finalized. So thanks for our audience for joining us today and sticking with us. Thank you to Lou and Heather for a great presentation. All materials will be available to you within a couple of days. The large FAQ might take us an extra couple of days. There are tons of questions, but we appreciate your active participation. So until the next one, have a great day, enjoy, and we'll be seeing you soon.